Good morning, everybody. Welcome back to lecture number 30. Today we have a very solid lecture, okay? Same as last time. So last time, what did we have? Do you remember this example? Example number 3. Which circuit did we use for example number 3? We use circuit 1. So the example number 3, we used circuit 1. And how to get the motor speed? Get the NM, in sync, which is 120 F over poles, and then times 1 minus a slip, 1 minus 0.022, you will get the motor speed. How to get the stator current I1? Find the equivalent impedance, which is R2 prime over S plus JX2 prime in parallel with the JXM, blow off the RM because it's infinity, in series with JX1 plus R1. Then V phase, which is 460 over square root of 3, divided by Z equivalent will give you stator current, which was 18.88 angle minus 30 something. A power factor is easy, cosine of the voltage, angle minus the current angle. We did talk about the power flow, and I told you the following. We start with the input power. Then we have some stator losses, copper losses and core losses. Then we have an air gap power PG. We also call it in the example P air gap. Both notations are good. Some of it would be lost in the copper losses, which is R2 prime over S, this component. And developed power, which is P converted, or in some book they call it P sub D. It's easy to know G will AG, صح? G gap will AG air gap. Does it matter? Doesn't matter. In developed power, people call it converted because it is the converted power from electrical to mechanical. Or they call it developed power. Developed power where? Not at the shaft, just before shaft. Just before الفريكشن والwindage والstrain. لأن بعد ما تصير develop من المagnet, I would lose some of it في الفريكشن والwindage والstrain. Sometimes the stray losses, they call it is 1% of P output. So sometimes it is 1% of the P output. يعني roughly speaking. The windage with friction is bigger. Sometimes we ignore the stray. The stray here miscellaneous. The developed power or converted power will be output power اللي تطلع في الشافت. And then this output power will be delivered to a load. What is a load? في حالة المروحة, I have my shaft rotating. صح؟ لما أحط مروحة, I will get my movement. فهل الموفمنت حقت الشافت supporting my load? Yes. لأن المروحة يحط هنا blade وهنا blade وهنا blade ودورها in the same axis of rotation you serve your load. طيب في السيارات EVs is it the same? No. كل كفر أحط عنده موتر؟ لا. نحط واحد أو اثنين. Then I have axis. وش يسمونه بالعربي؟ يلا حق السيارات. مو difference قبل الأكسس إيش؟ محور. المحور حق السيارة يكون فيه gearbox تروس هنا وهنا. once the rotor rotates الgearbox الديفرنس الgearbox would rotate بحيث ان المحور حق السيارة يدور بحيث ان الكفرين يدورون. تمام؟ فمعناته ان I have gearbox. فماي load is الgearbox بلس المحور بلس الكفرات بلس السيارة. طبعا في الاي فيز الموتور هنا وهنا الجير بوكس. another view for example هذا الجير بوكس you connect مثلا الروتر شافت هنا then this would rotate this would rotate this would rotate this would rotate وبعدين نحط الاكسس حق السياره هنا بعدين هنا كفر وهنا كفر. فهمتوا؟ هذه ميكانيكال انجينير you don't have to do. بس هذا الكفرات والمحور والجير بوكس is all the load. حتى هنا يقول لك في integrated الحين integrated electric motor يسوي هذا الموتور integrated مع الجير بوكس integrated مع everything. Here we have الموتور لا هنا only motor. But now you should have this understanding إنه sometimes I have gearbox connected هذا كله موتور. في هنا موتور بريك coupling reducer wheel. وصلت الفكرة؟ if I told you, remember, omega m should rotate as in the load and in the developed torque at the same speed, with induced torque is larger than the load. ايش معنى load؟ في المروحة is only the blades. في الاي في عبارة عن الجير بوكس بلس التايرز بلس الشاسي بلس الكفرات everything. فأنت you have to do all the calculations. ممكن سرعة الكفرات تختلف عن سرعة الشافت طبيعي. الجير باكس يكون سريع لما تحطه عند تروس ثانية تبطأ الحركة أو تسرع ممكن تسرعها. speed reducer or speed increase. What you need to know in the torque induced should be larger than load. Otherwise cogging حيصير بينتهي. يجي الموتور يبغى يدور ما يقدر يمشي.
إذا ما كان بنفس السرعة؟
إذا كان مو بنفس السرعة. إذا كان اللود أثقل من الانديوست تورك. Okay. Keep in mind these equations. These are the equations. This is the air gap, 1 minus S, converted, RCL is G. This is the air gap. You might get the air gap from a source minus the PSL. You get the air gap. But we did this example. We revise it real quick. Calculated the air gap power. طبعا this is line to line for 80, 60 Hz, 50 horse. عندي الكبر لوس 2 كيلو وات. الروتر RCL 700, الفريكشن 600, الكور 1800. Stray losses are negligible. What is the air gap power? Go back here. The air gap is the input power minus the SCL minus the core. The input power square root of 3 VT IL cosine theta minus the PSL minus the P core. The P core 1.8 kilowatt and the SCL 2 kilowatt. طلع عندك الاوتبوت 38.6.
واعطانا اياها البي كور.
Yes, it is given in the question. So the air gap is what? 38.6. بعدين 30 38.6, some of it lost في RCL. What is it converted or developed torque?
دي minus دي.
Yes. So you already have a rotor copper losses, 700. You subtract 38.6 minus 700, you get 37.9. Then,
دي out.
what is output power? Output power is
دي
rotational minus R. What is a rotation? Rotational, friction plus windage plus strain. He told you ignore the strain. What is a friction plus a windage? It's given in the question. Friction and windage are 600. So you subtract 600 minus 37.9, you get 37.3. Then here is a step, he converted it to 50 horsepower. Am I getting 50 horsepower? Yes.
That's from the
So it is from the problem also, have a quality check. Checking that output power should always be to the horsepower given. What is an efficiency? Output power over input power times 100, and output 37.3, and input 42.4. And this problem is solved. Easy? Easy. Let's go to the harder problem. Go back to circuit 3. Calculate the converted power. So, to get the converted power, I need an air gap power. صح ولا لا? Because if I know an air gap power, I subtract the rotor loss, I get it converted. But what is an air gap? An air gap عبارة عن an input power. Go to the equation. في problem عندي. في example 3, did I calculate I1 or I2? Wrong. I1. So do not go and calculate the air gap from this equation. Your only hope is to get an input power minus a PSL minus a P core. What is a P core in example 3? What is RM? Infinity. V square over infinity come 0. So ignore core losses. What is a PSL? 3I1 square R1. بمعنى minus PSCL. What is the input power? Square root of 3 V terminal I1 cosine of theta 1, which is the power factor, minus 3 I1 squared R1. I already know VT to be 460 from example 3, and I1 is 18.88. I forgot. كمل I1 for example 1. 18.88 angle minus 33.6. Now in this equation, do you put magnitude or angle? Only magnitude. You remember it has magnitude. So what is I1 magnitude? 18.88. So I have these numbers. What is R1? .641. So do the calculations. What is it P air gap? Calculators. Who doesn't have a calculator? Hmm? 10300. Okay, what is the input power? Square root of 3 times VT times I1 18.88 times power factor. What was the power factor? 0.833, صح? الانبوت باور is 12530 minus 3I1 square R, 3 times 18.88 square times R1, 0.641. So you should get 11,844. That's the air gap power. Let's check example 5. Maybe you used 480 or 460.
I forgot to multiply by 3. Yeah.
So 8, 4, 5. Yeah, don't forget the 3. So it is 11.845 kilowatt. So what is P converted? P air gap minus P rotor copper losses. I told you which equation to use for rotor copper losses. Don't use the hard equation, use SPG. So it is P air gap minus SP air gap. What is a slip? 2.2%. So this will be 1 minus 2.200 times 11.845 kilo. What's the answer? 1 minus 0.022 times 11.845, and you should get 11.584. 11.584 kilowatt. So go to example 5. If you go to example number 5, it is, I said 584, he said 11.585, it's the same. Okay? Then, we need to get an output power. How to get an output power?
Subtract the losses.
P output is P converted minus P rotational. What is P rotational? Is windage and friction. Okay, I forgot to include it, but go to example 3 and include it in example 3. So maybe I'll add it here. And windage is 1. So here, maybe we should add a note. P rotational is 1.1 kilowatt. Should be given, okay? So what is P rotational? 1 kilowatt. This should be given. Windage with friction, with stray losses, everything. It should be given. I'm not sure. So now consider it given. So what is the output? Should be 11.485 kilowatt. Let me ask you a question. Is this rated or not? How much I got? 14.1.
Okay.
Let's go back to question 3. Is there any indication in example 3 about rated? Yes, it is 25 horsepower. But I'm only getting 14. It means, am I having rated full load? No. I'm having 14.1 horsepower versus the rated حقها 25 horsepower. Why? Because this slip is not rated slip. It's operational slip.
Okay.
So this example is not operated at full load or rated condition. Clear? Clear? لأن لو كان rated كان مفروض يطلع الاوتبوت باور 25 زي الاكزامبل 4 طلع 50 هورس باور rated. Clear? Clear? اوكي.
السليب هو اللي حيحدد
السليب هو اللي يحدد. لو قال لك هنا اوبريت ات ريتد سليب اوف كذا وطلعت لك الاوتبوت باور ما هي 25 في غلط. اوكي؟ Let's go back. Now he plays games with any questions. So once we calculated the output power, now he wants to calculate the induced torque. Which formula he used? He used this formula. P air gap over omega sink. But I can tell you, if you also use this formula, P converted over omega m, you should get the same number. What is P converted? 11.585 kilowatt divided by omega m. What is omega m? You have to go back to example 3. If you go back to example 3, you would notice that omega m is 184.4, with omega sink 188.5. So let's put 184.4. Can you do by calculator?
Yes.
Did you get the same number?
Yes.
Yes.
Yes. So it should be 62.8 Newton. Newton. Newton meter. From where? From this chart. For an air gap, it's T developed times omega sink. P converted is T developed times omega m. So if you have omega sink, you can use an air gap divided by omega sink to get a torque, or the same torque you can get it by P converted over omega m. Okay? Now, what else he wants? He wants the output torque. The output torque, the only way to get it is what? طبعا هنا في D developed. No, that's not D. That's load, L. Load is P output over omega m. If you go here, it's easy division.
اوميجا ام اللي هو حق اللود برضه.
اوميجا ام حق اللود، اللود والكونفرتد باور نفس الاوميجا ام، مش اوميجا سينك. في الروتر سايد، الاوميجا سينك في قبل الاير جاب ستيت. فيو جيت 56.9 versus 62.8. Is it smaller?
Yes.
Smaller. السطحة لازم التورك حقها أكثر من السيارة تسحبها always. What is the efficiency? 83.7. This is a below average. The average, let's say 85. 88 good. 84, 83 below average. But it's okay. في الترانسفورمر كارثة لو عندي ترانسفورمر 83. بس في الاندكشن موتور it's okay. Is this example clear?
ما عندنا اي indication هل هو rated ولا لا صح؟
لا example 3 ما عندي indication. It is not rated. Why? Because the output power is 14.1. We're rated 25.
قبل question 25?
Yes, it is written. I just showed it before. صح? So it's not rated. A trick in the exam. And those who watch the YouTube video or attend the class will probably solve it. So what is the trick that I might ask the exam? Maybe in the exam I will tell you, let P stray to be 1% of P output. Let's P windage plus friction to be 1.1 kilowatt.
Okay.
What will change? What will change is P output will be P converted minus P windage plus friction W plus F minus 0.01 P output. So when I solve it, I should have 1.01 P output equals the number هذا 10.485 لأن 1.1 plus P minus P converted this, it will be what 10.84. بمعنى P output will be what 10.484 divided by 1.01, which will become
10381.
10.380. So if sometimes in the literature they tell you the stray losses to be percentage of the P output. So you have to solve this equation. Same for example 4. Clear? That's one of the tricks. Assume the windage will friction to be 5% of P converted. You will say P converted minus 5% of P converted minus let's say 1% of P out. يلعب كده. واضح التريك؟
Yes.
Sometimes he doesn't tell you the number, he tells you it's a percentage of another power. Or he would tell you, let P windage will convert it to be 5% of output power. So it will be P converted minus 5% of an output power. And then you solve this equation. Why? This is a trick. And I'm not saying it because I want to make your life difficult. It's because sometimes in the data sheet they tell you friction windage is 5% of rated output power. So it's your job to go to rate output power and calculate the windage with friction. Clear? But I have seen more stray losses to be 1% of our output. Very common assumption. Very common. Okay?
بس دكتور يعني لما يجيني في الشيء في الداتا شيت من المنطق اني افكر انه البي اوت تعتمد على اللود.
الريتد بي اوت 25 هورس باور.
يعني هو حيقول لي
إيه.
5% من البي ريتد اوتبوت بريتد.
بي ريتد فانت when you do calculations you stick مع البي ريتد و you assume. اوكي؟
بس ما راح تتغير لو غيرت البي اوتبوت؟
No. لا الرياليتي راح reality it will change. In reality it will change, but what will happen is what you stick with this assumption. It's the best assumption. ما تقدر كل مرة تقيس الويندج. خلاص 5%, 1% rotation is straight. Okay? So I need to open the book. I need to check something. So fake a quiz Thursday, induction motor on. Okay. We'll think about the additional lecture. Maybe sometime, maybe in the weekend, next weekend, maybe. Now, sorry, I have to check information. I don't want to give you the wrong information. So, let's say I'm gonna calculate the maximum torque. To calculate the maximum torque, I'm going to use circuit 2 because it's easier. So what is I2 prime? I2 prime is V over R2 prime over S1 minus S plus R equivalent. What is R equivalent? It's R1 plus R2 prime. What is X equivalent? X1 plus X2 prime. طبعا add the J, add the J, add the J, add the J when you calculate an impedance. So if you calculate I2, it will be,
Can I use circuit 2?
you have to use it, it's the only way. Otherwise, it will be very difficult. You have to use circuit. So what is I2? I2 prime is V over R2 prime over S1 minus S plus R2 plus R1 plus JX1 plus JX2, which is what? V over R2 prime over S plus R1 plus J X equivalent, where X equivalent is X1 plus X2 prime. Okay? Now, take the absolute value. If you take the absolute value, it will be square root of V squared over R2 prime over S plus R1 squared plus J squared, so it will be if you take the magnitude of a complex number 1 over A plus JB, it will be 1 over square root of 2A squared plus B squared, the formula for complex numbers IQ. So if you do this formula, you would have V over R1 plus R2 prime over S plus X equivalent squared under the square root. This is only magnitude. Phase angle is dropped. To substitute, developed torque is PG over omega sync. You agree with me?
Yes.
Fair air gap. And P air gap is what? The P air gap is 3 I2 prime R2 prime over S. So 3 I2 prime over S. So I think, that's why I opened the book, I think this should be like that. With that. I think. Okay? عشان كده أنا فتحت الكتاب. If you plug the numbers, no, shouldn't. I got stuck. I got stuck because I don't know. Does he? I think he has a P converted power. So this is not air gap. This is P converted power, and it has to be a function of omega m. So I know what's the mistake. So this is the mistake. Let's fix it together. This should be converted, and I will fix it later. This should be M. This should be M. This should be in. Now everything is in. I will fix it. I apologize for the mistake. So torque developed is P converted over omega M. The P converted is P gap. This is PG. Over omega M times 1 minus S. If you plug the numbers, you will have 3V square R2 1 minus S over S times omega M plus this complicated number. Is it clear now?
Okay.
So I will fix it. Take a photo and remind me to fix it the slides next time. Okay? It's easy to fix. Torque is P converted over omega M. P converted is PG times 1 minus S over omega M equal 3V2 square R2 prime 1 minus S over S omega M plus this bad ugly expression. Now here I lost the track, so let's fix the formulas as we go. So this is omega M. What is omega M? The angular, actual, mechanical shaft speed. Angular, actual, mechanical shaft speed. Okay, now it makes sense because if I change the speed, I'll change the torque. So this is wrong. So how to fix it again? This converted, this omega M, this omega M, this omega M, and this has to be omega. So if I take the derivative of this, I don't know how to take the derivative. It's take the derivative of a numerator with respect to denominator. You have to use the division rule, which is this derivative times that minus this. Math is hard. Equate it to 0, and then what is the slip that makes the derivative 0? It is this number, R2 prime over square root of 2, R1 squared plus X equivalent squared. So if I change the resistance, basically the geometry of the machine, I change the slip. Now we see some machines have slip 2% from these equations, or 3% from this equation. Maybe if I'm going to be very aggressive in the exam, I will tell you R2 is that, X equivalent that. What is R1 to give you the slip of 3%? I have to make sure you know this formula or not. Clear as well? Plug this maximum slip here. You should get this number. The maximum torque is a 3V square over 2 omega M R1 plus the other root of this. So for every machine, you can calculate the maximum torque by knowing the speed, the voltage, and the resistance and inductance. How do you get a V with R1 or R1 with X? You can measure it in the lab. You can measure it by ohm meter. Will you measure an inductance in the lab? You remember?
Yes.
What's the name of the device?
Inductor.
The device that measures the inductance. Multimeter, but multimeter is everything. But there is a device that measures the inductance to be specific. Did you see it in one of the labs?
I think it's 341.
341 they measure it, صح? 340. Who's teaching you 340? 341.
341 حتى الجوهر.
Dr. Omar Johar, he has this device. Only designed to measure inductance. It's more accurate than a multimeter. Because if you have it wrong, everything is wrong. So, you take this, how to fix this? So, you plot the speed from 0 all the way to in sync. هذه الان sync هنا. Correspond to it slip from 1 to 0. Why 1? Because if we start, speed is 0, slip is in sync over sync 1. If I reach all the way to in sync, slip is 0. So where is my start? My start here. At a torque, we call it starting torque. Then we increase if you plot these numbers, if you use MATLAB, and you change omega M only in an array and plot it TD, you should get this figure. You put it TD in x-axis, you should put it speed ns in the y-axis, you should get this maximum torque. Let me ask you a question. Where is nm rated? Is it here? Is it here? Is it here? Where?
Max.
Not in max. It is here. Here we call it slip rated or full load or by design, which give you this speed. Maybe this is 1800, this is 1710. So you operate at this rated torque. Most of the operation should be by design here. Mush here, wala here, here. You can't get pull out torque or maximum torque every time. You operate here, which is slightly lower, half of starting torque. I will show another curve. What is the torque here? 0. This is the x-axis 0. It makes sense. If I reach a synchronous speed, هل بيصير في change of flux? فالtorque is 0. Do I operate at in sync? No, I operate in sync minus a slip, which is a slip here. كم slip here? ممكن يكون 2%. Let's look at this curve. It's a better curve. Flip the axis of previous figure, add rated full load. هنا الفول load rated. And usually it is half of the starting torque. It makes sense. Why? لما I connect the machine وفي load, I need a higher torque عشان أدوره. من يروح الجيم؟ مو أول ما ترفع الوزن أول مرة. ما هو أثقل من ثاني ربس وثالث ربس. ليش؟ لأن في شيء اسمه pull out torque. تسحب من جاذبية أكثر. إلين ما يصير عندك pattern. Sometimes you need to pull out. Starting torque should be higher. أنت لما تشيل صندوق تتعب أكثر لما تشيله ولا وأنت شايله؟ أول مرة تشيله تتعب. خليك لما تتعب بعدين. أتكلم. Starting torque is required to push the car. نفس الشيء السيارة لما تدفها أول مرة. هل تحتاج فورس أقوى عشان تدفها؟ عشان تكمل دفع. فهذا starting torque. الماكسيمم torque it happens naturally يعني مع الدفعة القوية حتصير طبعا هذه from electric circuit. هنا ما هي ميكانيك. Then you reach a full load torque which is 100%. pull out torque between 400 to 500.
دكتور لو كان التورك بدلها
لو كان التورك هنا بيطلع التورك slip 1 slip 0. You have another axis of the slip هنا n.
ايه طب لو كان السليب في النص ايش حيصير؟
slip في النص هنا
ايه
we don't care about it. I don't know. حيقعد يمشي لأنه من هنا بعدين ينزل يثبت على الريتم. أنت لو زودت اللود
ايوه
you have to be careful. الفول لود very small margin لما توقف السرعة. إذا أنت قللت اللود حيزيد التورك. طبيعي لأن حيزيد التورك. هذه التريك حقت الاندكشن ماشين. مو إذا خففت اللود الكرنت حيثبت، الكرنت راح يتغير.
يعني لو حطيت لود ولا شلت لود برضه حقه بين هذا الريج.
Usually you operate here somewhere here.
والريج في البداية هذا طب بس كذا عشان
هذا في البداية when you start spinning الموتور. فالاندكشن موتور خداع. ليش؟ When you start you have a starting torque and then you reach a very full load torque. Maximum torque and then you reach a full load torque. Then once you reach it you connect your load. Or if you want to connect it from the beginning it's up to you. This is we call it torque speed curve. Every machine data sheet has torque speed. Usually it looks like that. Is it clear?
Yes.
So I added knowledge check examples from Dr. Mhaney. Try to solve them. They are very similar. I don't think I will solve them in this next lecture. Maybe we will solve them in the help session because we are So next lecture we will have synchronous. Okay? Any question?
The quiz is up. This slides only.
إلى الألعاب النارية. It usually include these. حنا we did similar example يعني حنا هنا مثلا هنا قال لك في this example calculate the line current with power factor. He had another way of showing it. Study it. I try to explain it in the help session. Or if we have time, maybe next section, or in the office hours. He calculated the magnetization current, he added it to the I2, then he got the I1. It's another way. Then he calculated the power factor. Then he asked him about the electromagnetic torque. How he got it is he got an air gap from 3I2 square R2 over S. Then he calculated developed torque over omega sync. Then he, in the last example, in the output power, he subtracted the rotational losses, meaning developed torque. He calculated the converter, which is developed. Then he calculated the output power. Then he added the input power, where he calculated the efficiency. Similar example, because it's additional. Okay? It's the same, we already explained. The only trick, the last part, and you can read it. So, okay? If you have any question, let me know about it. It's additional example. Maybe we'll solve it in the help session, but not later. Next session we'll start my synchronous. So now, do you understand the induction machine? Class is over. Please feel free to go.